Thank you for joining us. My name is Rachana Ananthakrishnan, and I'm the Executive Director of Globus at the University of Chicago. In the next 20 minutes, I'm going to discuss capabilities we are building at Globus for automation and accessibility of research data at scale. I'll start by touching on some of the key challenges we see in this space. All of us are well aware of the scale and heterogeneous nature of scientific data, whether it is data that is coming from observations and instruments or data that is coming from simulation runs from large compute. We're also seeing an increase in the compute needs itself. Very often, we are seeing the requirements exceed local resources, and researchers want to burst out into other resources. Sometimes it is because of capacity, sometimes it is also for specialized compute needs. All of this places quite a bit of a burden on the researchers. They have to determine how to manage their data, how to wrangle it to ensure that it's ready for them to do science. They also have to navigate the various interfaces that are available for using the compute resources. All this means they are spending time doing things outside of their core science activities. They are figuring out the infrastructure, and that drives a lot of inefficiencies in the process. Here at Globus, our mission is to increase the efficiency and effectiveness of researchers, especially in the data-driven science and scholarship area. And we try to do this by providing capabilities to researchers so that they can focus more on their science and less on the infrastructure. We deliver this as a data management platform today that provides core capabilities as hosted services to make it trivial for adoption and use. The capabilities are made available both as software as a service and platform as a service. So this means there is interactive access with a very low barrier of entry, and the platform supports automation and integration with their applications. I'm going to touch on a few of the core capabilities of this platform. So the first one I'll talk about is managed transfer. Researchers have needs to be able to move data around, whether it is across multiple systems for compute purposes, for backup, for sharing. Globus provides a managed secure transfer mechanism where a researcher can request for a transfer to be initiated, and all of the tasks associated with the transfer is managed by the hosted service. It ensures there's restarts, there's error handling, integrity checks, and also optimized, so you get the most out of the available bandwidth. So this allows the researcher to just fire and forget, request a transfer and walk away, and ensures that transfer at any scale happens for the researcher without them having to worry about it. The second solution here, a capability that is provided, touches at the heart of collaborative science. So we all know the researchers today work with collaborators across institutional boundaries, and there is a need to have a method to share data securely. And Globus sharing allows them to provide data access to their collaborators, very fine-grained data access, without replicating the data just for the purpose of sharing. So the researcher uses the Globus service to set permissions at a folder level for other collaborators to access the data, and the collaborators can then come in and copy the data. There's no reason to stage the data or create copies of the data, and they're just using their existing storage system. Now, all of these capabilities are provided across a wide variety of storage systems. Whether we are looking at standard POSIX systems that are available on-prem, or object stores, or you're looking at cloud storage systems, across all of these, the same interface and the same set of capabilities are available. So there is no reason to learn new interfaces and such for the researchers. Now, the fact that it's a platform is pretty key in all of this, right? Especially if you're looking at automation and scale. So all of these capabilities have public REST APIs, and we also have a CLI that is distributed. But this allows them to be able to be leveraged as a part of their application or their workflow. The platform has a slew of services, and I just want to touch on a few of these. So the first one that forms the foundation of this is identity and access management. So we have authentication services that plug into the federated ecosystem. We have groups that is used for access control. Then we have the data services. I've already touched on transfer and sharing there, but we also have a manifest service that allows the researcher to define a virtual data set that they can then operate on rather than at a file and folder level. This provides the abstraction needed to work at a scientific collection rather than be constrained by where the file is stored or where the folders are stored. The next service is search. We provide a scalable, secure search that allows for customizable schema to support research use cases. This not only allows discovery of scientific data, but also allows a visibility policy to be set to support embargoed data or private metadata and such. So at the end of this, you can have an interface where you have a faceted search where all the facets are relevant to the scientific domain where the data belongs. The next one is about persistent identifiers, which is a key pillar of research data management. Here we leverage DataCite, which has sort of been doing this in production at scale for a long time. And the collaboration with DataCite has allowed integration of some of the Globus security layers there so that users who are within the Globus ecosystem can leverage DataCite easily for obtaining identifiers for their data. And then the last one are flows. This is a service that allows us to pull together all these platform services to be able to perform a set of tasks. So I want to spend a few minutes talking about this service as it becomes essentially the backbone of our automation solution. We are building and envisioning a system that can automate data management across diverse systems and instruments, but also support human-in-the-loop activities. So with the Globus Automate platform, we are planning on supporting a method by which you're able to bring all these different tasks that are needed for essentially managing the research data, whether that is being able to do post-analysis reconstruction or having a user be able to look at thumbnail images and decide whether to collect more data or not, and have this all run in diverse resources, heterogeneous resources, but all pull them together as a pipeline for automation. So within the Globus Automate platform, a user can define a flow, where a flow is essentially a series of actions, and it is composed of a series of tasks. And that allows them to create a pipeline of tasks that they can then run, right? Now, the task can be anything. It could be an asynchronous operation. For example, it could be something that submits a job. It could be something that starts a transfer, or it could be a synchronous interactive operation, right? Maybe a web page where an administrator checks whether the flow should continue, or whether a curator checks to see if all the metadata has been provided and approves a publication. All of these are also part of interactive tasks in the pipeline. So flow allows a composition of these tasks that can be defined once and then run over and over again for automation. The flow can be triggered using events. So again, this could be events such as a file system write, availability for a particular file or a resource, or it could be something as simple as a user triggering the start of a flow. Each of the tasks, which are called actions in the flow, it's customizable, and an action provider is written or implemented for what that action will do, right? The action providers, a set of them are distributed by our platform, especially for the ones that we have core capabilities. So obviously we have transfer, data permission management, ingest to a search index. All these are action providers that Globus supports that can be one of the steps in the flow. But we also have other teams writing their own custom action providers. Potentially it could be to interface with compute or do metadata extraction or a web form where somebody is filling in data and such, right? So with these customizable action providers, you can then construct flows that are specific to your needs and then can be run over and over again for scale or automation. Now for the Second half of this presentation, I am going to use some science examples where all of these core capabilities, including the Automate platform, have been used, and talk about how it is applicable and how we were able to achieve some of the scientific goals for automation here. So the first one I'm going to talk about is a effort called City COVID. So this is a effort which is very relevant to the current pandemic we're in. They are building a model of the spread of COVID-19 across the population in the city of Chicago. And the goal really here is to get data that the city of Chicago publishes on the current status, and then run what-if models. What happens if this population, adheres to some guidelines? What happens if there is an outbreak in one part of the city, and so on? And the model is being built at a very high level of granularity with 3 million agents representing individuals in the city and over 1 million sites that represent institutions and homes and so on. As you can imagine, what they're trying to do here, time is of essence, so the results are relevant only if it can be produced at a particular period of time. And this takes significant compute, right? So at a very high level, they wanted to scrap the data from the reports that were published by the city of Chicago, perform simulations, and because we needed big compute, they were using the leadership class facility, Argonne leadership class facility, for computing these models. And then there was some additional post-processing that was using other compute resources at Argonne, and then ultimately make their results available to their collaborators, potentially people in the city of Chicago, and so on. So we decided to take this use case and we worked with them to automate it so that this could be done, every day. The first thing they needed was some way to interface with compute. So for that, a action provider called FunkX action provider was built. FunkX is a service. It's again a service, a National Science Foundation funded effort that's happening at the University of Chicago, looking to provide function as a service platform for high performance compute. It essentially is a way of transforming clouds and clusters and everything into a high performance function serving system, right? And the idea here is that the compute resource deploys a FunkX agent, and it gives a single ubiquitous interface for applications and users to interface with, to be able to submit their jobs, scale their jobs, run it on heterogeneous compute systems and such. It is built using some of the security services that Globus has. It interfaces with Globus Transfer for moving the data and such, but also uses portable code like Python, Singularity, and Docker is used, and it provides an API for access. So this is one of the key pieces that is part of the solution set for City COVID. So they could use FunkX to be able to submit jobs across these diverse compute resources. The second piece of infrastructure that they needed was a place to store and serve the data, the whatever results that was being generated, right? So in collaboration with Argonne Leadership Compute Facility, there is a service that's available at Argonne called Petrel, which essentially has multiple facets. Two facets of Petrel that was used in this project is one, a project data store that is tuned for collaborative sharing, which means it's sitting in a location in a network which allows high performance data in and out. It also has set up security policies such that you can share data sitting there with others. And the second one, which is critical here, is being able to allow user managed data sharing. So they used Globus sharing capabilities to allow the PIs to then share the data with their collaborators and their cohort, and there was no sort of admin in the loop. It was all completely managed by the administrators. So if you look at this, then the City of COVID workflow really had some authentication, who's allowed to run this. Then they used the FunkX action provider to submit jobs that essentially scrap data from the City of Chicago published information. Then they ran simulations. Then they transferred the data into another compute resource for further post-analysis and such. And then they used Petrel. They moved the data again to Petrel. and set permissions for people to be able to access the data, right? So this is the workflow that they had to run. The simulation run was brought down to about 30 hours, and they were repeatedly running this to provide near real-time data and analysis of how things could change and what the effect of some of the policies are, or opening up the city would look like. So they were able to provide input to the decision makers to be able to consider that as they made policies, right? Now, in this case, the users who were accessing the data were just using the Globus web interface, and they were able to browse and pull down the results, right? Whatever they needed was available to them on Petrol storage and accessible through Globus. Right? So this is one example where we were able to take something that they had to repeatedly do, make it into a flow, and then just run multiple instances of it at a good clip to be able to provide information that was of critical essence in a timely manner. The second science application I'm going to touch on, it's XPCS, it's X-ray photon correlation spectroscopy out at the Advanced Photon Source at Argonne. Here, typically somebody brings in a sample and they want to essentially get images out of this, right? So the first step is they do imaging at Advanced Photon Source. The data goes to an acquisition server. And then they have to move to a completely different security domain to be able to do reconstruction of the data. Once they do that, they get some plot results, and then somebody looks at it, and then they decide whether they like it or not, and then full reconstruction runs. And then when it's available, it gets ultimately moved to Petrol, the data store that I talked about, for publication, with the goal of allowing other people to access their data. They also wanted the scientists to be able to come in, sub-select data sets, and then run additional post-analysis, right, on ALCF. So they didn't want the researchers to have to install all the analysis programs elsewhere or find compute resources elsewhere. They wanted a very simple interface for them to come, browse the data, sub-select, and then go ahead and run post-processing analysis on it. Here, they needed a couple of additional things to support this on Petrol. So as a part of the Petrol data services, we have deployed customizable search indices for discovery and access. So the XPCS data that gets stored in Petrol, one of the steps would be to extract metadata that's relevant to that scientific domain and push it to a search index so someone can come and search for the data. And we also needed a portal to provide that user interface into all of these complex data that's available or the compute that needs to be done, right? So as you can see from these images here, you can customize this portal to have facets that are relevant to the domain. You can have thumbnail images. So you can really make this rich set of capabilities and data accessible to the users through this interface. So with all this available, this is how their flow looks. So again, there is authentication. You have to know who can do this. They transfer the files, and then they transfer a second set of files that are generated. They run analysis on the leadership class machines. Then there is plotting of results that happens. Then the next step here is an ingestion. So they extract the relevant metadata. They put links to files that the metadata references to. They create thumbnail images so you can see some of that information. And then they transfer the results out and then set permissions. So only the people who are running the experiment can see some parts of this data. Some of it is open, some of it is not. So all of that is managed. This is a repeatable flow, but also something they need to customize. So sometimes they have to come in and make tweaks to this flow, right? And that's another piece of the automation platform where the flow is is defined in a pretty user-friendly language. So you don't have to write, you don't have to be a programmer to do this. Somebody who's a beamline scientist or a researcher who's not into computer science and coding can still look at the flow and make tweaks to it and run it. So with that, we have a really nice data discovery interface for the XPCS users. They can browse. They can also create manifests of the data as needed, so they can do selection, and then they can run reprocessing. So they can ask for a subset of the data to be reprocessed, which triggers an automated flow that has been created for them. Right? All of this made possible using the simple portal interface. So with that, I want to leave resources if you're interested to learn more. Globus.org is the main website for us, and you can see more examples of this and learn about our production infrastructure and some of the work we are doing for automation. Thank you.